Hello everybody. Still kind of getting myself organized. Sorry about that. Hopefully I turned on my audio. Looks like I did. Uh, okay. Hello. So we're on slices. So I'm going to start just by reminding you about arrays really quickly, because arrays were a good way to prepare to use slices. Also, I want to. Today is April 14th. Just remind you about what we got going on this week. So let's do the dues first. What's due? Lab 11 is due. And then what are we up to? So I'm going to review arrays really quickly. Introduce slices, and then hopefully I will make time today to get you started on project 3. So that's my planned activities for this week. Got a new setup here, which hopefully fixes the audio a little bit, but sorry, it also gets in the way of me drinking, and by the afternoon I've been broadcasting for about 3 hours by now, so my voice is starting to get roughed up. Okay, so that's what's going on. Project 3 is due. Let me bring up my browser. Project 3 is due on May 1st. So this week is a great week to get started on this project. It gives you 1 week, 2 weeks, about 3 weeks to work on it. This one is harder than the others, so just heads up about that. This project is more challenging, so you need to read the project, try to get a sense of what the requirements are, and then start working on it bit by bit by bit. At least that's what I recommend. I'll try to give you a little bit of help. What does my starter code do? My starter code will clear the screen, which is kind of cool. And also we have, and I'll come back to this, I have some pictures taken from my own implementation. This isn't, obviously I don't have the program for you to run, but I'm showing you what my program displays as you run it, so you get a sense of how I've formatted it, how I'm presenting the user with their menu options and those kinds of things. So please consider starting Project 3 today, and if I have time, I'll probably do something along those lines while I'm broadcasting today. Okay. So arrays. I'm just going to do this review right here. So arrays, an array is collection of data, or if you want to think of it as a collection of variables, that's fine. Arrays can hold any type of data, but one array, but all items in a given array are all of the same type. So if you have an integer array, they're all integers. If you have a string array, they're all strings, and you can't make one array that has both strings and integers, or floats and bools and integers. If you have a float array, it's all floats. If you have a string array, it's all strings, and so on. They have a fixed size. So for example, we can do var numbers, which is an array of 10 integers. Once you've sized an array, it will always be that size. It's 10. You can't make it smaller, you can't make it larger. An array size is fixed the moment that you create it. The size can be accessed with the leng, so a lot of people think of it instead of the size, the number of elements, they think of it as the length of the array, but it's the same thing. The length of an array is the number of elements in it. So the length of numbers is 10. Individual pieces of data are accessed using indexes. So for example, I can say numbers at 0 equals 99, and 0 is always for every array in the universe in Go. The index 0 is always the first element. So this is the first integer in this collection, and what I'm doing is I'm assigning a value to it. You can also use that to do things like print them. That would be the last one in the numbers array, which is one less than the length is the last index. So anyway, you access the individual values in an array with an index and the square brackets. Hopefully many of you will remember that. And then the last part that I want to review for you is that you very often, and one of the powerful things about arrays is that you can write a very small amount of code to process entire collections of arrays. So an example of that would be this loop, which would let me very efficiently, for example, very efficiently print all of the values in the array. I could format them if I wanted to. And I can even use that I for part of the output. So the value at 0 is something, the value at 1 is something, and so on. Hold on, I'm getting a lag. Okay, so with loops, you can also do a loop this way. Let me separate these out so I can label them better. So you can process them with counting loops for I equals 0, I less than the length of something, which in this case is the array you want to process, I plus plus. You can do things like print all the values. You can also do things like increment all the values in an array very efficiently, so that will add 1 to every value across the array using this loop. And you can use a range loop. So you have the choice of either of those loops when you're processing an array, but they are one of the things that's great about arrays, is that they can be processed with these loops, so you can do a lot of work on a lot of data with a small amount of code. Okay, so that's most of the important stuff about arrays. So I'm going to introduce slices, and we'll go sort of play around with slices a little bit in code. So the neat thing about slices is that almost everything about them is exactly the same as an array. So they are collections of data. Everything in one collection has to be of the same type. So an integer slice is all integers. You can access the size with the len, the length function. You use indexes to access the individual pieces of data. You can use counting loops or range loops on them. But slices can be altered in ways that arrays cannot. For starters, you can append new elements to a slice. So in other words, they are not fixed size. Arrays are fixed size, slices are not. So if you have a slice and you want to add a new element to the end of it, you can do that, which is quite handy. They can be created completely empty with 0 elements in them, or of any size that you want to start. So arrays, when you create an array, you have to pick the size. And once you pick a size for an array, then you're stuck with that size. Slices, you can actually create them as being completely empty with no elements in them, literally length 0 to start, and then start adding elements to them over time. So they're very, very flexible in that way, and kind of super neat. I lean on them way more heavily than I do arrays because they're so flexible. So when you create a slice, you can actually literally create it with 0 elements in it, length 0, or you can create it with 1,000, and then you can add 1,001, 1,002. Whereas an array, you have to pick the size, and then you're stuck with that size. And then the last thing I would say, even I use my own words for this because this is how I understand it. You can make windows onto slices. That let you view and change parts. And I'll show you an example of windows today when we look at a code sample. That's not what they call them in the Go language, but that's the term that I like to use for it, is a window. But I'll show you what that looks like in a second. In the Go terminology, they call that I know I have the words for that somewhere. In Go terminology, they call it, oh yeah, slice expressions. So to me, the idea of a slice expression isn't that meaningful, so I call that a window, but I'll show you what I mean when I do a slice expression, sort of toward the end of the examples. Okay, so what is a slice? It's mostly exactly like an array, except for it's a lot more flexible. You can change it, you can append to it, you can create it with nothing in it to start if you want to. But in most other ways, you can't tell the difference between a slice and an array. Okay, so now let's make a little bit of code, just to experiment a bit with slices. Okay. I'll get an import in there in a second. So first I'll make an array just to remind you. So we'll do maybe we'll make strings, I guess. Sure. So that's a length 5. And I'll just remind you some of the basic things that you do to experiment with an array. So for example, you can use the len function. That will say it has 5 elements. Now I'm going to do just a contrast as I go. I'm going to do a slice. I'm going to start. I'll do a string slice. And let's just see what that looks like when we run the program. So the flowers array contains and see what we get. We know that fruits is going to be a size 5 because we can see that, but we want to see what does flowers do. Notice it's hard to even distinguish it from an array. The difference is that there's no number in there. And that's a clue that this thing is different, obviously, but it's also a clue to me that the size is negotiable, that the size is flexible possibly since I didn't have to code it in there. But let's just see what Go thinks of it when I try to run it. So the first one, the array contains 5 elements as expected, and then the flowers slice contains 0 elements. So like I said in my little setup notes, slices can literally have nothing in them. And now what we'll do is let's put a flower in there. So the way you add an element to the slice is you say, I want to make a new version of flowers to be the result of appending to the old version of flowers some new element that can go in flowers, which will be a string, so I'll put a daisy in there. And now if I do the print, I'm going to see that after I put the daisy in there, it's going to have 1 element in it. Contains, not contains, contains 1 element. So this is something that slices do that arrays do not. You can append to them and make them grow longer over time. That's kind of nice. Let's print. I'm going to put a separator here so you can see that's where we break from the array to the slice, so I'll keep those separate. So let's do a counting loop on each of them. To print out the contents. I'm actually going to make it look kind of like an array. So I'm going to print out fruits in the square brackets, and then I'll insert an integer in there, and then on this end a string. So the integer part will be the I, that's the index, of course. That goes where the %d is, so it'll be fruits at 0, fruits at 1, 2, 3, and 4. And then I will print, then I'll use the index to access the specific piece of data in the fruits array. Now I'm going to do the same thing after I've put a daisy. Let's put a couple others just for fun. I'll append rows, I'll append running out of a petunia. So there's 3 elements, and then I'm going to use a counting loop also for this one to print out its contents. So for I equals 0, I less than the length of flowers now, I plus plus, and I'll print out maybe with a slightly different, so flower number, and then I'll put the index there, is, and then I'll put the actual flower name, the string part, so I'll use the I, flower number 0, 1, and 2, because there will be 3 of them, and then I'll index flowers at I. This is to show you that it's the same loops, you just switch out the array, it's the same indexing, it's the same length. The only difference is, at least so far, the only difference is you can make an empty slice and you can add new things to a slice and make it bigger over time. So I've added 3 elements onto my slice. Oh yeah, I expected the fruits to do that because it's in its 0 state. So there actually are no fruit actual words yet. But there's the daisy, the rose, and the petunia appended, each of them, to the back. Okay, so they're very, very similar, except for slices have this append capability and arrays do not. But the counting loop works the same. Setting up a slice, there's 2 ways to do it, and I'm going to show. We'll do another way of doing an array, but the var way of doing a slice is to not put a size in there, and then you just get an empty slice that you can append to. The var way of doing an array, of course, is to put the size of the thing in there. Okay, an array, a slice. Let's make another slice. So now let's focus in on slices for a while. I just wanted to point out to you that slices are going to use the same skills that you practiced with arrays. Slices just give you added flexibility. Okay, so now let's do the other kind of slice. So a slice that starts with the size. So you can't do this. I'll do a... I don't know what I'll do. I'll do a... distances. Doesn't really matter. Is that what I want? Sure, I don't care. That's an array, right? So you can't put a number in there and go and have a slice because it's an array. So the way you make a slice is with the make function when you want to make a slice that has a size. So I'm going to make a slice of integers that has 5 integers in it. Now I can see from this that it's a slice because it's the square brackets with integer and no number in there. So this is how you can create a slice that starts with a desired size. You'll get used to, like the project 3 will give you a chance to kind of pick between slices and arrays and decide which you feel more comfortable about. To me, the 2 things that make slices particularly useful are the ability to add new things to them and also the ability to make windows on them. And I'll show you windows here in just a second. But anyway, so slices can start out as empty or they can start out with elements in them. It's up to you based on what's going on in a program. You can also, by the way, make that 5 a 0 and create an empty slice that way. That would be the colon equals style of making an empty slice. But let's just say we're going to make a slice of 5. It's going to be all zeros. So in Go, if there's not preloaded data, then it's zeros. But anyway, you can still do this then, which is the cool thing. Since it's a slice, I can still append to it, even though it already had stuff on it, but it starts out as 5 zeros, and now it's going to be 6 elements, 5 zeros into 99. In this case, I'm just going to remind you that you can do a quick and dirty view of an array or a slice with %v, which will just sort of spit out everything at once. The reason we're doing this is just to see our 5 zeros followed by 99. So there's our 5 zeros followed by 99. That's not pretty printed, meaning I put no effort into formatting it like I did in the other places, but I quick and dirty printed it so that I could see my 5 zeros, 1, 2, 3, 4, 5, and the 99 that I appended on the end of it. So you can create them with a starting out size and then add things on later, which is kind of cool. Oh, and we can all, well, do I want to mess with that? No, not yet. Not yet. I just want to show you the various ways that you can make a slice. So let's make a you can also make a slice that's preloaded with data. So I can say averages equals, so making a slice of float 64, and then I'm going to populate it with data. And then I'm going to do a thing. I think Baby Doll's in here with us today, are you? Maybe. Oh yeah, you are. Hello, Baby Doll. Brought up a thing about commas, so let me just show you. It's pretty common for people to set up arrays and slices with the brackets set up like I've done it, and then they put their values in a row like this. So this is a slice, and I know that because the square brackets has no number in it telling me it's an array of a fixed size, so it's a slice, which means I can append to it. But what I've done is I've preloaded it with some data, which means that I've given it some starting data other than zeros, plus it has a starting size that I can then append to. So the starting size is 4. The index of the first element is 0. The index of the initially the last element is 3. But this comma right here is required in this case. So if you sort of bust out preloading an array or a slice across multiple lines like this, the last line has to have a comma or you get an arrow. The reason why they do it that way is because in the old days, when we would write it like this, and then we would go add another element, we'd forget to put a comma before the newly added element. And it's just so irritating that some languages actually just make it a rule now that when you have them top to bottom like this, the last one has a comma, which means when you add a new one, you kind of just already naturally have the comma sitting there. So if you're set up like this, that last comma is in fact required. Alright, so 1, 2, 3, 4, 5. This is a length 5 float. I'm going to compute the average of the averages just for fun, to show you how I'm working on this. So in this case, I'm going to give myself, I'll call it overall average, so we're less confused about what it is. Okay, so I'm going to range loop this time. Range over averages. So just like arrays, you can range loop over slices. It automatically figures out how many elements are in there and thus how many times it needs to range and pull this pair of values. So it's going to pull First, the index at 0 and its associated average, which is 73.567, and then do with it whatever it's supposed to, and then it's going to pull index 1 with an average of 67.89, and then index 2 with 99.999, index 3, 91.12, whatever, index 4, 89.978. So on the left is the singular. That's the one, that's the pair representing one element in here, starting at index 0 and its value, the average at index 0, as it ranges over the entire collection of averages, the plural. What I'm doing is I'm going to accumulate the sum onto that overall average, and then I'm going to let's call that the sum. That seems kind of sloppy to not call it the sum. So we'll sum it, then we'll say the overall average is the sum divided by the length of the averages. So notice, just like an array, except for it's going to compute the length of the slice as it is right now. I remember from last week that if I divide the sum, which is a float, by the length, which is an integer, I'm going to get an error, so I'm going to use type coercion to avoid that error. And then I'll print the overall average. I'll go to 3 decimal places just for fun. Oh good, okay, I forgot to mention it, but let's inspect this error and see what it's. So in line 49 it's saying I have an I that I declared but never used. So let's see what that means. Line 49. Okay, so in line 49 I have an I here, but inside this loop I never actually use the I for anything. I only use the average part. When that is the case, I need to tell, just like with arrays, I don't want that part. So I'm going to use an underscore, which the Go language will understand to mean just ignore the I part. I don't need it. I have to account for its existence, but I don't have to use it for anything. So this underscore tells the Go language I'm ignoring that part. And now I get an overall average of 84.511. Okay, so most of that, I mean, it's a kind of a lot of mess to look at. Slices and arrays aren't very different. Slices are more flexible because you can change their size over time. You can append to them, which is super handy in a lot of different applications. Where you start out, well, I know I have 3 to start, but they might add more later, so I'll use a slice and then I can append as they add more later. You might imagine, for example, a playlist in a music player. A slice would be a good thing to use for a playlist because a person, you don't know how many songs are going to add to their playlist, so you start with an empty slice, and then every time they add a new song to the playlist, you append to the slice. An array couldn't do that. An array, you'd have to just say, well, it'll be size 100, and if they want more than 100 songs in their playlist, I can't help them. So that's an advantage of a slice. Okay, the last thing, which is going to seem possibly a little intimidating at first, but it's not that bad, and it's quite cool. So I'm going to make a slice. Actually, I'm just gonna, how do I want to do that? Let's do something slightly fancier here. So let's make an empty slice for strings called colors, and then I'm going to write a loop that lets the user just keep entering colors in until they decide that they're sick of it. So I'm actually just going to use a forever loop for this. Yeah, I'm going to use a forever loop. So I'm going to set up myself a string. So next color, I will prompt them. So enter, type, let's see, enter a color, or just hit enter to stop. So they're either going to type in a color or they're just going to hit enter, in which case I'm going to stop it. Okay, so I'm going to scan. And then here's the tricky bit. So if I'm using the lang, by the way, I think I can do that in Go. We'll find out. I'm going to use the length on the color. If it's greater than 0, that means I'm going to assume they typed in a color. So I'm going to update the slice by appending to the slice the color they typed in. That's if the length of what they typed is more than nothing. Otherwise, if what they typed in was nothing, meaning they just hit enter, then I'm just going to break this loop. So that's slightly fancier, but it's a good example of what a slice can do to you, for you, which is, I don't know how many colors they're going to type in. They'll just keep typing until that one where they press enter and don't actually type any letters, at which point I'll assume I'm done. So when we're done, let's just start by, you entered this many colors. And we'll use the length of the color slice just to see what they entered. Let's experiment with that and see how it works. Okay, so here I am with enter a color or just hit enter. If I just hit enter, perfect. I did. I entered 0 colors. But now let's do it in actually red, blue, green, yellow, purple, yellow, purple, orange. And now if I just hit enter, meaning I don't type any characters, then my program's just going to say, okay, we're done. So I think I entered 1, 2, 3, 4, 5, 6, and that's what my slice shows has been appended to it. So I set this one up just so you could see a slightly cooler example. I feel like I'm seeing lag on your end. I hope the internet isn't broken. I've been having internet issues today. Perhaps I said something seditious. Okay. So that's an example of where you can enjoy the power of a slice, because with an array I would not have had the option to just type as many colors as you want and I'll append them. That's a slice thing. But now what we can do is we can use slice expressions, or what I like to think of as windows on a slice. That's how I think of it. Windows on the slice. So I'm going to do the first 2 colors are, now I'm going to use %v here, which is a quick and dirty print, but I just want to show you how these slice expressions work. So you can actually take a slice and you can tell it that I want to start at index 0 and go for 2. This I think of as a window. It's a window that starts at index 0 and covers a count of 2 elements in the slice. Go calls it a slice expression. But I like the idea of a window better. So what this should show me is the first color and the second color, and then that's 2 colors. So the first number is where to start, and the second number basically is how many. That's not totally precise, but for now let's just think of it that way. So I'm going to go run it and type in my colors and see if I can use a window just to show the first 2 colors. So red, blue, green, yellow, purple, orange, sage. Hit enter to stop. And there's the first two, red and blue, that I got by using that slice expression or that window just to focus in on those elements. You can also do the last two. This one's trickier. I'll use the quick and dirty print for this. Alright, this one's trickier because you have to use the length. But let's see what happens. So I'm actually going to use the length of the slice, less 2, to go to the end and come back 2. And if you don't put a second value in the window or the slice expression, then it goes from the starting place through to whatever the end of the slice is. It turns out, by the way, on the first one, if you don't put the 0, then it assumes that it means you want it to start at the very beginning and go for 2. So it can take that 0 out. In this case, I'm going to start 2 short of the length and go through to the end with that window. So red, blue, green, yellow, orange, sage. Hit enter. So orange and sage, those are the last two that I entered. Red, blue are the first two, and that's using slice expressions, or what I think of in my head as windows on a slice. I just cut a little window in to look at from the beginning up to, and I cut a little window in the second one going from the end, coming back to, going through to the end. So first two, last two. You can also get things like you can get things that are somewhere in the middle. So I could start at like index 2, and let's just say go to index 4. So what this actually gives me is indexes 2 and 3 and pull up short of 4. So technically this 2 up here is actually 0 and 1, pull up short of 2. Anyway, so start at 2, pull up short of 4. So there's green and yellow. Starts at index 0, 1, 2 is green. 4 is orange. So you notice it's pulled up short of orange and stopped at yellow. So it went index 2, index 3, and then pulled up short of index 4 is how those are expressed. So you can make a window at the beginning, at the end, anywhere in the middle. And there are cases where that's a handy feature to have. Okay, I've used a decent amount of time, so I think I'm going to stop there. That's just introducing you to the concept. So on Thursday at 2, we'll do the lab, where we practice these skills on some lab problems. So right now, I will stop and I'll entertain. Oh, we want to talk about Project 3, but I'm out of time to do that, aren't I? Yeah, we're going to have to make time to do that. Bummer. Okay, well, let's just do a quick starter and see what it has for us on Project 3. Let me at least get you doing something on Project 3. Okay, so if you notice on Project 3, you should read it, think about it, ask questions, but the starter code actually sort of gives me a little bit of hints. So I'm going to copy that into a file in here. And let's see if we learned anything today that's of use. There is a screen clearing function, so I encourage you to try it. Okay, so this program says, did I show you the browser? I did. This program says we are implementing some kind of a spreadsheet that uses arrays or slices of floats. So I need 5 arrays or slices of float 64 values. These represent the spreadsheet rows. Okay, so 5 arrays or slices of 5 float 64. So since we're fresh on slices, and this will be the only thing that I do to get you started, but I have the starter code here. This I downloaded from the project itself. It has a clear screen function in it. Create the slices. I need 5 of them, and they represent the rows. If you look at the pictures, you can see the numbered elements 1, 2, 3, 4, 5. So those are the 5 rows. There are 1, 2, 3, 4, 5 values, and then this other piece is, if you've used Excel spreadsheet, this is like the formula cell. So you punch in 5 values, and then this one does a calculation with them. So I have 5 of 5. In code, I could do this, row 1, and I could make a slice of float 64 that has 5 elements in it. Now I can use arrays if I want to, but I was just talking about slices, so why not play around with that? The starter code kind of tells me where I should be doing this. So as a starting point, I could make the 5 rows, row 1, row 2, row 3, row 4, row 5, and already have addressed part of the program. Main program loop. So loops tend to look something like this. And for starters, I can just sort of plug in something that looks like a loop. I'm going to tab those over so they look pretty. Clear the screen. There's a function for that. Display all the rows. Well, I haven't worked on that part yet, but that gives me something I can work on. Display a menu. That I know how to do. And if I'm in doubt, I can just steal the menu off the sample here. The menu that I'm shown in the sample is 1, edit cell, 2, change operation, and so on. So that I can handle. I may not know what all those things do just yet, but just sort of pointing out to you that you can begin to sort of spin up a little bit. And hopefully most of you have done a menu, so you know kind of how to do a menu. Ask your user to make a choice from the menu, scan the menu choice in, and then write a switch or something to go where you go. And so on. So that's just to give you some idea about how you might begin to get a little bit of code going. And now I have sort of officially used my amount of time. I could show you the code again because I didn't take the browser off. So I worked in, that's all I did is kind of show you where you might begin to sort of plug in some pieces and get yourself started. Okay, so stopping talking, and I'll wait for your questions if there are any. Okay, lab 12. Just confirming that I'm getting the right ones. Okay, so let's start with that one. List of shortest returns a slice containing all strings in a given list whose length matches the shortest string in the list. Okay, so this one, the results are a string slice. So that part we know. So this is a two-part problem. You can't make a list of the shortest unless you know what the shortest is. So the first thing you got to do is use your own function and get the length of the shortest string in that list, which is from the hint, length of the shortest. So I can't make a list of all the strings that match that length unless I already know what that length is. So I use my own function to figure out what's the length of the shortest string. Now I can simply, doesn't really matter. I'll grab strings out of the list with a range loop. So if the length of the string I pulled is the same as the shortest one that my other function already computed for me, then I keep it. I notice here, by the way, that inside of my loop I don't use the I, so I'm just going to ignore that piece. And that probably solves the other function as well. I mean, it's not exactly the same, obviously, but the same approach. Shouldn't. It shouldn't. No, in fact, I know it won't because I used that in today's code somewhere. Yeah, I did. So it shouldn't, unless you don't have S matching. So that S right there is the same S that I'm pulling with the range loop. So this should work. There's no reason why it shouldn't. Um, the only thing I can think of then is that you change something. If your length of shortest, check your length of shortest function. If you've changed that, then you broke it. This assumes that you didn't change my functions, that you implemented them as presented. So if you change this, then you broke it. Okay. So that's good, because I thought maybe you accidentally changed one of the other functions that would make this break. So as long as you didn't change the functions as they're set up, then yeah, it's got to be a typo or something. Okay, I'm going to sew things up here. So I will be here at 10 a.m. tomorrow morning, Wednesday, for question and answer if you want to drop in. Right now I'm doing COBOL programming because I've gotten curious about that in light of recent news. If you don't know what that is, just look it up. Okay, so you append to a slice without duplicating input. So like in my colors thing as an example, I'll show you on colors. So back here in my earlier example when I was doing colors, one of the checks I did to see if I would keep a color is whether or not they actually typed any characters in. But the other thing that I would do here is I'd make myself a little function basically to ask the question, does my colors already have that color? And then if I don't, that's what the bang means. So I'd write myself a little function. I'll show you what that function would look like, where I pass in the list of colors and the color that they're trying to add and double check to make sure that I don't actually already have it. So the have color function would look like this. Where I pass my slice of colors and then the specific color I want to see if I have it or not, and then return true or false whether or not I have it, and then I would range over this. Range over colors. If the color that I pulled in my range loop is the same as the color that's being tested, then I would return true. I have it already. I don't need the I in that loop, so I ignored that. Now if I manage to get down here in this function, so this for loop will just bounce out. If I find a match, then true. If I manage to process the entire set, the list or slice of colors, without ever returning true, that can only mean that I didn't have the color in question. So I would write myself a little helper function that I used to help myself figure out every time I type a color, do I already have that color? We can test that, and I'll show you by typing the same color twice. So red, blue, red. Oh, I forgot. If I put the same color twice, I break, so we don't want that. Let's write the logic a little bit different. So if it's a good string, and then if I don't have it already, I don't want to break on a duplicate color, I just want to ignore it. Something feels wrong. Okay, it's okay. So I'm going to check the length, make sure it's, and then after that I'm going to check to make sure I don't already have it. So that should prevent the crash. So red, blue, red, green, red, 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 orange. Should only be keeping the red once. So it only took the red once. I should have printed them all to prove it, but 1, 2, 3, 4, I ignored the duplicate red. So that's how I would do it, is with this little function to help me check. Sure. Okay, so tomorrow at 10 a.m. And if I don't see you then Thursday at 2 we'll work on the lab. If I find time, I might press forward a little bit on Project 3 or answer your questions about it. But please look at Project 3. Please at least get a handle on what's required. It's a challenging project, so you don't want to wait too long to sort of start putting some code in there and seeing what it feels like.